Hi everyone, in this video I'll be going through chapter 11 worksheet number 3, solving basic Trigo equations, and now we're going to start to learn how to solve a bit more complex kind of Trigo equations, which is actually very similar to solving algebraic equations, okay, which may involve sometimes you may have to square root both sides or factorize in order to solve. So we'll illustrate this using examples. Let's look at example number 1. Okay, let's solve this equation here. 2 cosine square equals to 1. Okay, so similar to an algebraic equation, imagine if I have, let's say I write the side for comparison, 2x squared equals to 1. What do you do with this? Very simply, you make x squared the subject, half. Then after that, to find x, I take square root. Then it will be a plus minus square root, half. Okay, same thing, instead of x, now this just becomes cosine theta. Steps are the same. Okay, we make cosine the subject first. I will have cosine square theta equals to half. Therefore, this means that cosine theta, I take square root on both sides. Since I'm square rooting an unknown, I should have a plus minus square root of half. Okay, therefore, from here, I will have cosine theta is equal to positive half, or cosine theta equals to negative half. Actually, square root half can be rewritten as 1 over root 2. I hope you can see that, 1 over root 2, and square root half negative 1 over root 2. Okay, so therefore, the steps are the same as solving a Trigo equation from here. Next step, I want to find identify the quadrant first. So we draw a simple ASTC diagram to help us visualize ASTC. First one over here, cosine theta is positive. It lies in the, let me do a highlight. Cosine theta positive. It lies in the first and fourth quadrant. Let's write that down. Here, theta lies in first or fourth quadrant. Similarly, in this case here, when theta is negative 1 over root 2, this means it lies in the second or fourth or third quadrant. In this case, theta lies in second or third quadrant. Okay, so from here now, I can now find the reference angle first once I've identified the quadrant. Alpha equals to cosine inverse 1 over root 2. Okay, take note that this question is in radian measure, and you should also recognize that 1 over root 2 is a special angle. If I cosine inverse 1 over root 2, I will get 45 degrees, but since this is in radian measure, it is equivalent to pi over 4. Okay, similarly, alpha is, even though this is a negative value, remember, whenever I find reference angle, I only take the positive value here. So this means that cosine inverse is 1 over root 2 is also equals to pi over 4. Okay, so this means that the angle can lie in the first, second, third, or fourth quadrant. I have the same reference angle. So therefore, this means over here, maybe let me minimize this. Theta is simply equals to first quadrant, pi over 4, second quadrant, pi minus pi over 4, third quadrant, pi plus pi over 4, fourth quadrant, 2 pi minus pi over 4. Okay, but over here, we need to also recognize that if you see, we check the range again, theta is between negative pi and pi. Okay, if I look observe what I'm given over here, we note that pi plus pi over 4 is more than pi. 2 pi minus pi over 4 is also more than pi, which means that these two answers over here is out of the range. We have to reject these solutions here. Rejected. Okay, and rejected as it is out of the range. So we need to think, are there more solutions within the range? From here, if I have pi minus plus pi over 4, if I subtract away minus 2 pi, this will become negative pi plus pi over 4, which is within the range of negative pi and pi. Okay. Likewise, if I have over here, this solution here, 2 pi minus pi over 4, I minus away one cycle. Maybe I put another arrow here. Minus away one cycle, minus 2 pi. I will get negative pi over 4, which is also within the range over here, okay, stated by the question for theta. Okay, therefore, final answer to this question is simply pi over 4, 3 pi over 4, okay, this solution here, negative pi plus pi over 4 is negative 3 pi over 4. And the last one, negative pi over 4. And these are your 4 solutions for example 1a. Alright, so I hope you can follow. The steps are the same, it's just that now I'm solving a bit more complex Trigo equations. Let's now look at part B. Okay, part B here, I have 2 sine square x minus sine x minus 1. This is also similar to solving algebraic equation again. Remember, if I have 2x squared minus x minus 1 equals 0, what should I do? I should first factorize them equals 0, then either this is equal to 0 or something equals to 0. Then I solve, right? Steps are the same, but now instead of x, it becomes sine x. Okay, so let's work that out together. Okay, let me erase this. From here, let's work out 2 sine square x minus sine x minus 1 equals 0. By factorization, I hope you can see that this can be factorized into 2 sine x plus 1. Oops, let me write it in red. Wait, 2 sine x plus 1 sine x minus 1. Okay, you can either use your cross method or your tic-tac-toe method to factorize this. It can be a working at the side over here. So for example, if I use the cross method, whichever method that is comfortable for you to help you factorize this, 2 sine square x negative 1 minus sine x. So I'll get 1 sine x 2, then over here it will be a minus. So by multiplying, I'll get sine x minus 2 sine x. Okay, so you can also use a multiplication frame. The steps are exactly the same to get this factorized form over here. Okay, after that, from here, this means that either 2 sine x plus 1 is equal to 0 or sine x minus 1 is equal to 0. Therefore, this becomes a very simple basic Trigo equation to solve. I'll get sine x equals to negative half or sine x equals to 1. Okay, so let's start solving the left side here first. Sine x equals to negative half. The steps are exactly the same. Step 1, identify quadrants. If I were to draw out my quadrants, A, S, T, C. Okay, alpha is equal to sine inverse half. Therefore, sine inverse half, this is a special angle. Question is in degree, so write all angles in degree. Sine inverse half is 30 degrees. Okay, so over here, wait, before that, I haven't identified the quadrant yet. Sine is negative, it means that it is in the third and fourth quadrant. X lies in third and fourth quadrant. Okay, so therefore this means that since I found the reference angle, x is equal to 180 degrees plus 30 degrees, or 180 degrees, or not 180, sorry, 360 degrees minus 30 degrees. Okay, and I'll get 210 degrees and 330 degrees. There we check the range again. X is only between 0 and 360 degrees, so this is one cycle. Therefore, these are the only solutions within this range. Okay, next one. Sine x equals to 1. Actually, from here you can get the answer straight away. How to do that? Let's quickly draw out the Trigo graph for you to imagine in your head. I hope you still remember how the sine graph looks like. Sine graph looks like this. Okay, this is one cycle, 360 degrees. Okay, for a sine graph to be equals to 1, which part of the sine graph does it occur at? I hope you still remember. For a sine graph to be equals to 1, it occurs at this value over here. Okay, what is the angle here? If you still remember how your sine graph looks like, half a cycle is 180 degrees. It hits 1 at 90 degrees exactly. So this means that if I have sine x equals to 1, you can tell straight away, therefore, this means that x is equal to 90 degrees. Okay, because it only occurs at 1 x value, which is 90 degrees. Okay, so therefore from here, therefore we have found the 3 answers to this question. Therefore, solutions, we combine all the answers together, are 90 degrees, 210 degrees, or 330 degrees. And this is your answer to example 1b. Okay, great. Now let's look at the page 2 now. Okay, we are going to start to learn how do we use identities to help us solve Trigo equations. Okay, so whenever your given equation has more than one Trigo functions of x, what we always want to do is that we make our equation into just one form of Trigo function so that we can solve it easily. So this is what we have learned before. This is the Pythagorean identity, which can be found in a formula sheet, and so these three are part of the Pythagorean identity. We have also learned that tangent is sine over cosine, and cotangent is cosine over sine. Okay, let's look at example 2a now. Find the angles between 0 and 360 degrees which satisfy tangent square y plus 8 secant y equals to 1. So from here, by the Pythagorean identity, we know that tangent square y we can use this to turn it into secant square. Okay, remember when I want to solve Trigo equation, to solve this sort of very complicated thing, right? Easiest way is to make everything the same Trigo function. In this case, because I have a tangent square, I can turn this over here. So for example 2a, this means that tangent square x is equal to secant square x minus 1. Okay, so therefore we continue downwards. 4 tangent square y plus 8 secant y equals to 1. I can replace tangent square y by secant square y minus 1. Okay, so over here this means that this is equal to secant square y minus 1 plus 8 secant y equals to 1. Okay, from here moving forward, I expand and simplify, I'll get 4 secant square y plus 8 secant y. Okay, this is become minus 4. Then subtract 1 from both sides. I'll get minus 5 equals to 0. Okay, then from here, very simply, I see you can imagine this as 4x squared plus 8x minus 5. How to solve this? Simply factorize this kind of quadratic equation. So I draw my working at the side. If I use the cross method, I'll get let's see, I have 4 secant square y minus 5, 8 secant y, secant y, secant y. Okay, one must be 5, one must be 1. To get 8, I should have 2, 2, 10 secant y, 2 secant y. The minus should go here. Okay, so therefore this means that I will get 2 secant y plus 5 times 2 secant y minus 1 equals to 0. Okay, this means that 2 secant y plus 5 is equal to 0, or 2 secant y minus 1 equals to 0. Therefore, to solve this quadratic equation, I will simply make secant y the subject. So this means that secant y is equal to negative 5 over 2. Over here, secant y is equal to half. Okay. Therefore, we continue downwards from here. Okay, this means that over here, remember secant. What is secant? Secant means, I draw at the side, secant y is equal to 1 over cosine y. Remember, for reciprocal functions, you always look at the third letter, c. Okay, so this means that cosine y is the inverse of this reciprocal, which is negative 2 over 5. Over here, cosine y, I flip this fraction, it is equal to 2. Okay, then from here, I know that cosine y is equal to 2. Remember cosine y graph. How does your cosine y graph look like? I do a quick sketch for you to visualize. This is my cosine y graph. Cosine y. A cosine, maybe this will be cosine x, okay? But regardless of it, I know that the maximum value and minimum value of cosine is always between 1 and negative 1. So cosine y can never be equals to 2. Therefore, I will have to reject this portion here, rejected, as cosine y is between or equals to negative 1 and 1. Okay, so I reject one solution. I will have to now solve for the other solution here. Let me make everything smaller. Okay. Okay, so over here, cosine y equals to negative 2 over 5. Now we work with this. Steps are exactly the same. Identify quadrants first by ASTC. I draw a ASTC. Okay. cosine negative value, negative value means it is in the second and fourth quadrant, second and third quadrant, okay, so this means that y lies in second and third quadrant. Okay, so next step, find reference angle. Alpha is equal to cosine inverse 2 over 5. Press in the calculator. This question is in degree mode, 0 to 360 degrees. You should get 66. Let me calculate. Cosine inverse 2 over 5. 2 over 5. Okay, you should get, let me check again. Okay, I need to get my, okay, wait, 2 over 5. 4. This is exactly 66.4 degree. Okay, 66.4, not exactly, you can write off to, let's say, 2 decimal places. I'll get this. Better to write as 5SF. Okay, but from here I'll get 66.42, which means that in the second quadrant, y, remember this section is y, so second quadrant will be 180 degree minus 66.42 degrees, and in the third quadrant it will be 180 degree minus plus 66.42 degree. Okay, therefore calculate this final answer round off to 1 dp. You should get 113.6 degree and 246.4 degree. This is all rounded off to 1 dp. Okay, and this is for example 2a. Alright, so over here we reject one solution here because cosine y is only between -1 and 1, and we can find 2 solutions over here. Okay, there's a bell ringing, I don't know why. Okay, let's look at example 2b right now, the last question for this worksheet. Okay, so for example 2b here, find the angles between 0 and 2 pi. Identify straight away, question is in radian mode, okay, which satisfy 3 cosecant z equals to 2 secant z. So let's simplify from here. 3 cosecant z equals to 2 secant z. What we want to do is to make them into, simplify these reciprocal functions to make our life easier to solve them. Okay, I know cosecant, reciprocal function, look at the third letter. Cosecant, it means it is 1 over sine z. So this means that this is 3 over sine z, because it is 3 times 1 over sine z. Likewise over here, secant is 2 over cosine z. Okay, 2 times 1 over cosine z is 2 over cosine z. Okay, then from here, if you notice, right, let's carry out the fraction first. 3 cosine z is equal to 2 sine z. Okay, now, how do I solve this? I have 2 different sine and cosine. How can I turn them to just one trigo function? There's no square, there's no identity I can use. Remember, we have also learned that tangent is sine over cosine. So that means that if I can get a sine over cosine, I can turn this into tangent. How to do that? I simply divide both sides by cosine. So I rewrite the left side to be 2 sine z. This will become, by rewriting this, this will be sine z divided by cosine z is equal to 3 over 2. Okay, I divide 2 on both sides and I divide by cosine z on both sides as well. Okay, therefore this means that tangent z is equal to 3 over 2. Okay, therefore from here, steps are exactly the same now. Identify quadrants by ASTC. This means that z lies in this is positive, so therefore it lies in the first quadrant and third quadrant. In first/third quadrant. Okay, so this means that the reference angle now is tangent inverse 3 over 2. Press in the calculator, radian round off to 5 SF. We should get, let's calculate that. Okay, so let's calculate that. Tangent inverse 3 over 2. I will get in radian measure 0.983, sorry, 0.9279, 98279. Okay, this is what you get. Okay, so therefore this means that, let me shift this here. Okay, this means that Z in the first quadrant is simply 0.98279. In the third quadrant, it is pi plus 0.98279. Okay, check the range of values, angles between 0 and 2 pi, which means that over here I want Z to be between 0 and 2 pi. Okay, so therefore, this is one cycle, it satisfies the range over here. Okay, no need to plus or minus any cycles. Final answer, I can run off to 3SF, I should get 0.983 radian or 4.12 radian, rounded off to 3SF. Okay, and with that, we have completed the examples in this worksheet. Okay, so please go back and try the practice questions first. Okay, I'll go through the practice questions once we have completed them. Then we will then work on the homework afterwards. Alright, so this will be the end of this